So it's a nice segue from Robert's presentation to mine, because I want to talk about basically giving farmers options to use agricultural biodiversity in their production systems to deal with climate shocks and climate change and to create more resilience. And I want to focus on three areas. One is around public policies, the second is around knowledge, building knowledge and evidence, and the third is around the role of conservation and seed systems. So first on public policies. In addition to continued research on staple crops, which we also talked about yesterday in the nutrition session, we need to be investing more in looking at a broader diversity of crops and tree systems that can help farmers adapt to climate change. Biodiversity and some of our partners have documented that we are seriously underinvesting in crops other than the main staples, and that this, over the long term, will weaken global food security, especially in the face of the continuing climate change uncertainty that we've been talking about today. We need a concerted effort to increase our investment in research and development, in identifying agronomic practices for these crops, seed systems that can deliver farmers solutions to farmers. Second, we need to support farmer-bred varieties. In India, for example, farmers are allowed to sell their own varieties, which are often quite well adapted to their local climate conditions. And this policy of India's allows for a stronger seed system. Yet in many other parts of the world, farmer-bred varieties are not recognized by the governments, and they can even be illegal to sell. This, again, severely affects the diversity of seed systems and limits options for farmers. We need to also open up gene banks and improve the links from gene banks to farmers. Many farmers don't know that they can request material from gene banks, and of course don't know what is there. There is a need to provide farmers with more information and more adapted accessions in order to manage their existing risks and future risks posed by climate change. We need to develop and make available crop varieties, particularly of these so-called neglected crops that are more resilient to weather shocks as being suitable for changing climate conditions. We also need to encourage diversified production systems with diversified seeds. In many countries, farmers are only using a few varieties of seeds, even though many different varieties exist that could help them deal with climate. We need to develop adaptation strategies for the major crops based on local genetic diversity, conserved either on farm or in the gene bank. This material can be used as the basis for innovative breeding systems. The World Vegetable Center, for example, Gene Bank, for example, now possesses more than 430 species of vegetables, with at least some of these capable of growing in every niche agricultural environment currently known. We need to do more research to find out where we can use these varieties and how they can be integrated into farming systems. Biodiversity is researching how we can use informal and sort of intermediate farming seed systems, if I could call them that, and improve those to supply farmers with a diversity and increased quality of seeds. We need to also think about diversifying value chains. Farmers won't plant diversity if they can't sell it. We need to identify ways to add value and improve post-harvest options for diverse farming systems. There are literally hundreds of indigenous edible vegetable species that could be exploited for use in changing environment. African indigenous vegetables, for example, are capable of responding quickly to first efforts at crop improvement through plant breeding and have already been developed ready markets in African cities. Biodiversity has been working with millet in India, both helping farmers to identify varieties that are suited to their climate, but also working with partners to develop food products. We have also been working in the Andes with partners in quinoa, which of course everyone knows now has become a very important crop, both for the Andean farmers, but also for consumers around the world. Nepal, for example, changed their agricultural development policy in the early 2000s to provide more support to farmers in the highlands. One method that they used was to encourage agricultural biodiversity. And back to millet for a second, India has been incorporating millet in purchase programs, which is also increasing farmers' interest in growing this crop. We have new opportunities in Africa to integrate agricultural biodiversity into policy. This is the 10th anniversary of the Comprehensive African Ag Development Program, as we heard last night, and CADP is putting forward new visions for agriculture in Africa to adjust policies and investments across the country, across the continent. And we need to look to see how we can integrate the use of agricultural biodiversity into those policy solutions. In terms of knowledge and evidence, each year 10 to 16% of global harvests are lost to plant disease. Using diversity allows farmers to limit the spread of pests and diseases without having to invest in expensive inputs. And in Uganda, for example, biodiversity research has shown that pest and disease damage was substantially reduced by just planting a diversity of beans, varieties of beans in farmers' fields. We have similar successes with rice in China and bananas in Uganda. Through an initiative called Seeds for Needs, Biodiversity is working to provide farmers with varieties that are better adapted to their existing climate conditions. In Ethiopia, for example, we've been working with farmers in durum wheat systems, identifying 400 varieties that were already in the Ethiopian gene bank and identifying about 30 of those varieties that would work in farmers' systems, and we have been testing with farmers those systems and looking at what traits they can bring to farmers, including drought tolerance, reduced or increased growing cycles, flowering times, and pest and disease resistance. To summarize, we are building and we need to build more evidence that biodiversity production systems can enhance resilience and can help farmers adapt to climate change. And this knowledge and these practices need to be mainstreamed across farming systems. And finally, we need seed systems and conservation systems, both ex situ and in situ, to ensure that resilience and climate adaptation is possible. Our Seeds for Needs program, which I mentioned before, was actually a direct result of researchers and, frankly, farmers seeing a need to use diversity that was existing in gene banks to help farmers adapt. I'm trying to cut my time, so just give me a minute. In addition, Biodiversity has been leading research teams in 8 countries, including Uganda, Rwanda, Cote d'Ivoire, and Burkina Faso in Africa, to engage in novel research activities to use crop diversity for climate adaptation. With support from the Genetic Resources Policy Initiative funded by the Dutch government, we are combining high-resolution climate data with data on crop suitability, geographic information, and gene bank accession coordinates to identify crop genetic resources that could be used in these vulnerable sites. So what actions can we take today? We need to encourage the development of goals and policies with agricultural biodiversity as an integral part of solutions to climate change. We need to increase research funding, especially for diverse crops that can increase resilience, and we need to empower local organizations to drive local and national adaptation strategies for these crops. We need to invest in seed systems and in conservation, especially in situ conservation of the diversity of crops and crop wild relatives that can help farmers deal with climate change. And finally, we need to develop and cultivate relationships with farmers to improve their understanding and conservation and use of agricultural biodiversity. Thank you.
Thank you so much, Jen, for this